What if the asteroid that wiped out the dinosaurs hit Earth today? Not in some distant sci-fi future, but now. In our hyperconnected, fragile, overpopulated world. Would we have a chance to survive, or would it all be over in less than 10 hours? Scientists estimate the original asteroid was just 10 to 15 kilometers wide, but it unleashed energy equivalent to 10 billion Hiroshima bombs. Oceans boiled. Skies turned black. 75% of all life gone. And now, imagine this. What if a similar asteroid is already heading toward us, and we simply haven't seen it yet? In this video, we'll explore what would really happen from the first impact warning to the last human breath. And trust me, it's worse than you think. Hit like, subscribe, and let's go. Today, humanity stands at the peak of its technological evolution. Satellites orbit our planet, monitoring every square meter of Earth's surface. Supercomputers process data in real time. Artificial intelligence assists in predicting natural disasters weeks in advance. We've mapped near-Earth objects, tracked their orbits, and built early warning systems that can alert entire continents within minutes. On paper, we are prepared. But here's the uncomfortable truth: despite all our advancements, our planet is still terrifyingly vulnerable. Over 27,000 asteroids pass near Earth every year. NASA confirms that hundreds are classified as potentially hazardous, large enough to destroy cities, regions, or even entire nations. And yet, most of them go unnoticed until they pass us by. Our systems are not infallible. Telescopes miss objects approaching from the sun's direction. Many smaller observatories lack the funding to maintain constant surveillance. And in recent years, several sizable asteroids have slipped past us, some within a lunar distance, completely undetected. Now imagine a world bustling with over 8 billion people, cities stacked to the sky, supply chains stretched razor-thin across continents, and a global economy balanced on algorithms and trust. In such a delicate system, a single catastrophic event could spark a domino collapse. We live under the illusion of control, but the truth is, Earth has been struck before, and it will be struck again. The only question is when. And when it does happen, will we even see it coming? It began 66 million years ago with a flash of light in the sky. A massive asteroid, roughly 12 kilometers wide, struck the Earth near what is now the Yucatan Peninsula in Mexico. It hit with such force that the energy released was over 1 billion times greater than the atomic bombs dropped during World War II. Within seconds, the impact vaporized everything for hundreds of kilometers. Shockwaves circled the globe. Fires raged across continents. A towering tsunami, possibly over 1,000 feet high, devoured coastlines. But the true extinction didn't come from the blast. It came from the sky. Dust, ash, and vaporized rock were thrown so high into the atmosphere that sunlight couldn't penetrate for months. Global temperatures plummeted. Plants died. Then the animals. Then, silence. Nearly 75% of all species were wiped out. Dinosaurs, dominant for over 160 million years, disappeared in just a geological blank. And yet, for decades, scientists debated whether such a thing truly happened. The breakthrough came in 1980, when Nobel Prize-winning physicist Luis Alvarez and his son Walter discovered a thin layer of iridium-rich clay and rock strata all over the world, a rare metal common in asteroids. It was a fingerprint left by the killer. Since then, we've learned more, much more. We now know that Earth crosses paths with countless asteroids, some potentially even larger than the one that ended the Age of Giants. And history, as it often does, has a pattern. What wiped out the dinosaurs wasn't a random accident. It was part of Earth's natural cycle. Which means it could happen again. Not millions of years from now, but in our lifetime. Right now, over 1,200 near-Earth asteroids are classified as potentially hazardous, meaning they are large enough and pass close enough to cause regional or even global devastation. One of them, 99,942 Apophis, is nearly 400 meters wide. That's taller than the Empire State Building, and it will pass between Earth and our communication satellites in 2029. Closer than the Moon. Closer than many might feel comfortable knowing. If an object of that size were to strike a populated area, the impact would release energy equivalent to hundreds of nuclear bombs in seconds. But what about something even bigger? Something the size of the Chicxulub asteroid that ended the reign of the dinosaurs? Here's the chilling truth. We don't have a plan. Not a real one. While there are experimental missions like NASA's DART, designed to nudge asteroids off course, these technologies are in their infancy and only work if we detect the threat early. Very early. And that's the problem. Many space rocks, especially those coming from the direction of the sun, are nearly impossible to see until they're frighteningly close. In 2013, a 20-meter asteroid exploded over Chelyabinsk, Russia, completely unexpected, injuring over 1,500 people and damaging thousands of buildings. That asteroid was never even on our radar. Now imagine something 20 times larger, traveling 10 times faster. The blast would flatten cities, ignite wildfires across entire regions, send shockwaves that break windows and bones alike hundreds of kilometers away. This isn't a Hollywood scenario. It's math. It's physics. It's just a matter of timing. And that timing might already be ticking. Here's something most people don't know. An asteroid doesn't even need to hit the ground to cause unimaginable destruction. In fact, the most dangerous ones might explode in the sky. It's called an airburst. When a large asteroid enters Earth's atmosphere at tens of kilometers per second, the pressure and heat become so intense that it disintegrates violently, releasing all its energy in a blinding mid-air explosion. This isn't a theory, it's already happened. In 1908, over a remote part of Siberia, a 50-meter object exploded in the atmosphere with the force of 15 megatons of TNT. The shockwave leveled 2,000 square kilometers of forest. Trees were flattened radially like matchsticks for miles. No crater was ever found. And for years, people had no idea what even caused it. Now imagine something twice that size, detonating above a modern city. The heat alone would ignite everything beneath it. Glass would liquefy, steel would twist, and people wouldn't even have time to scream. Some scientists argue that airbursts are more likely than ground impacts, because Earth's atmosphere acts like a trigger, causing premature detonations. But here's the twist. While ground impacts leave craters we can study, airbursts leave almost nothing behind. No crater, no fragments, just trauma. That means we might be underestimating how often they occur and how many have happened without us even realizing it. Some researchers believe ancient cities were destroyed by airbursts mistaken for divine punishment or forgotten entirely. We measure time in centuries. The cosmos measures in eons. So the real question isn't, what if? It's what already happened and what comes next. In recent years, scientists have made incredible progress in detecting and tracking near-Earth objects. NASA's Planetary Defense Coordination Office now monitors thousands of asteroids and publishes regular updates. Telescopes like Pan-STARRS and NEOWISE scan the skies every night, mapping potential threats. One of the most ambitious developments was the DART mission, the world's first real test of planetary defense. In 2022, NASA deliberately crashed a spacecraft into the asteroid Dimorphos, successfully altering its trajectory. It was a groundbreaking success, but also a sobering reminder that was a controlled test on a harmless asteroid, known years in advance. In a real emergency, we might not get that luxury. The European Space Agency is also developing the Hera mission, designed to study the aftermath of DART and refine our models. Other proposals include nuclear deflection, solar sails, and even using gravity itself to gently pull asteroids off course. The science is evolving fast, but not fast enough. Many of these technologies are still theoretical. Others require years of planning, precision, and international cooperation, something humanity often struggles with in times of crisis. Worse yet, we still have blind spots. Objects approaching from the sun's direction remain nearly invisible until they're dangerously close. And despite everything, we've only mapped a fraction of what's out there. The unsettling reality is this: we may have the knowledge, the tools, and the minds, but what we lack is time. One missed alert, one late discovery, and everything we know could become part of Earth's fossil record. For every official report, there's an unanswered question. For every successful test, a shadow of doubt. Some scientists argue we're closer than ever to defending Earth from a catastrophic asteroid. Others warn that we're dangerously overconfident, distracted by simulations while reality moves faster than our models. There are even theories that governments already know about a potentially devastating object, but are withholding the information to avoid mass panic. Is that paranoid? Maybe. But history shows systems break under pressure. During the Cold War, near misses with nuclear weapons happened multiple times due to faulty data and human error. Now apply that same fragile decision-making to a rapidly approaching asteroid. Some believe the next impact won't come from the sky, but from within. That political chaos, misinformation, and lack of coordination could cause us to fail, even if we technically had the tools to succeed. Others ask a darker question. Should we even try to save ourselves? In a world plagued by climate change, overpopulation, and extinction-level biodiversity loss, is an asteroid nature's reset button? It's a haunting thought, but one that lingers. Because the real threat may not be the asteroid, but the human response to it. Panic, division, denial. One scenario shows the world uniting, launching defense systems, surviving. Another shows silence, secrecy, and then fire raining from the sky. In this moment, as sensors flash and telescopes lock on a new object crossing Earth's orbital path, we're forced to confront a simple, terrifying truth. Technology may buy us time, but it cannot save us from ourselves. The asteroid entered the atmosphere at over 70,000 kilometers per hour. Within seconds, satellites picked up the thermal signature, but it was already too late. A fireball brighter than the sun tore through the sky, triggering shockwaves that shattered windows 500 kilometers away. Then, impact. A detonation equal to hundreds of nuclear weapons. Cities near ground zero vanished in a flash. Forests became flame. Oceans pulled back, then roared in, tsunamis devouring coastlines across hemispheres. But beyond the physical destruction came something deeper. Silence. Global networks collapsed. Supply chains froze. Panic spread faster than any warning system could handle. In the chaos, old rivalries ignited and cooperation fractured. Some nations turned inward. Others blamed each other. But the damage wasn't just infrastructural, it was psychological. For the first time in modern history, humanity faced a shared trauma and a shared reckoning. What good were our satellites, our warnings, our AI-driven defenses, if none of it could stop the fall? Scientists who once debated impact probabilities now debated survival strategies. Governments rebuilt in bunkers. And people, those who remained, stared at skies that once meant wonder, now filled with fear. Some say this was the beginning of a new era of forced evolution. Survivors adapted, changed, united in some places, divided in others. There were those who viewed the asteroid as a cosmic judgment, others as a second chance. But one truth echoed louder than any explosion. Our greatest vulnerability wasn't space. It was believing we had more time. And in the aftermath, that belief died, along with everything else that once felt permanent. In the end, the asteroid was not just a cosmic event, it was a mirror. It didn't simply destroy cities or collapse systems, it revealed who we really are. Stripped of our infrastructure, our technology, and illusions of control, what remained was choice. Do we rebuild the same fragile world, chasing the same comforts that made us blind? Or do we evolve, and not just scientifically, but ethically? That's the real question now. The impact forced humanity to face its deepest weakness, the belief that progress is permanent and time is infinite. But it also revealed a rare strength that even in devastation, we can choose. Some communities began to live differently, prioritizing sustainability, decentralization, resilience. Science wasn't abandoned, it was reimagined. Technology wasn't worshipped, it was grounded in humility. And yet, others clung to the old ways, rebuilding concrete towers where forests once burned, dreaming of the same systems that had failed before. The world stood at a crossroads, a moment between extinction and transformation. This wasn't just about surviving an asteroid. It was about learning why we were so unprepared and deciding what future we truly deserve. Progress always comes at a price, but so does ignorance. The next impact, whether from the sky or from within, will test whether we've learned anything at all. The question isn't whether humanity can be saved. The question is, who will we choose to become before the next stone falls from the dark? So now, let's go back to that very first question. What if the asteroid that killed the dinosaurs hit Earth today? After everything you've just seen, does that question still sound like science fiction? Or does it feel closer? More personal? The truth is, the asteroid isn't the only threat. It never was. The real danger lies in what we ignore, in what we postpone, in thinking that tomorrow is guaranteed. Maybe that's why this story matters, Because it's not just about extinction, it's about awareness, about responsibility, about realizing that we're not separate from the history we read about. We are part of it. Right now, maybe you're watching this in a quiet room with your phone in hand, feeling far away from any falling rock. But that's exactly how every extinction begins. In normalcy, in routine, until it isn't. And that's why I'm sharing this with you, not to scare you, but to make sure you remember. Because stories like this don't end in explosions. They end in choices. So I'll ask you this, personally. Do you think we're ready? And more importantly, what would you do if tomorrow morning we saw a new light in the sky growing brighter every second? Let me know in the comments. I'd really like to hear what you believe. Because maybe, just maybe, the next chapter starts with us. Don't forget to like, subscribe, and share this video. Someone you know might need to hear it.